Well, dear students, now in this video I am going to discuss and tell you about mass effect and binary energy of nucleus. I have told you that nucleon means proton, neutron are tightly bound in very small region and very large density. I told you 2.3 into 10 to the power 17 kg per meter cube is the nuclear mass density. So nucleons are very close to each other, and for this, actually, you know, gas molecules are far apart from each other. There is no force of attraction, and the gas get liquefied and then solidified when temperature is decreased. When temperature decreased, so it means a sufficient amount of energy has to be liberated or released by the particles of gas to form a solid. For example, vapor, steam is obtained by heating water. The molecules of vapor has larger amount of energy than molecules of water. So to convert vapor into water, some energy has to be withdrawn from the molecules, and that is done by cooling that. We cool the gas. Then when liquid is formed, you want to make ice. So again energy has to be withdrawn. So when nucleon have come to such a very nucleon in the nucleus has come very close to the other at distance of some Fermi, then how much energy is to be released? That energy release cannot be obtained in any chemical change or physical change. Actually, here I am discussing all these things because I have discussed this topic with many learned people, because I was not clear about this topic, why the energy is released. But unfortunately, nobody could explain me. Then I had a long meditation and I got it, why the energy released. Very simple. To liquefy a gas, the molecule has to be brought closer, so there extra energy to be taken out. And when you want to solidify a liquid, again large amount of energy to be taken out. For example, in case of water and ice, to make ice of water, 80 calorie of heat energy to be withdrawn per gram. In nucleus, nucleon are very close to that. The large amount of energy has to be released, has to be taken from the nucleon. That much energy cannot be obtained in any chemical change or physical change. So what happens there, we will see here. So what is mass effect? From mass spectrography, I told there is device which is called mass spectrometer. Mass spectrometer measures the mass of ions. The atomic masses and masses of small particles are measured. very precisely. It is found. This sentence I have written only just for sake of knowledge, but it starts from here. It is found that mass of nucleus of an atom is found slightly less than the sum of masses of protons and neutrons present inside when they are free. Free means outside nucleus. Sum of mass of proton, neutron outside nucleus was measured and mass of nucleus was measured. The mass of nucleus of an atom is found slightly less than the sum of masses of protons and neutrons present inside the nucleus, inside it, when they are free, means they are out of the nucleus. Unka mass when they are outside nucleus. This difference of masses, this difference between the sum of masses of constituent nucleon and the nucleus is called mass defect. The difference in the mass, sum of mass of nucleon inside the nucleus and the nucleus, mass of nucleus is called mass defect. Actually, this is the definition. Sometimes you are asked, what is my mass defect? So you have to write like this. Now, suppose we have, suppose an atom ZXA. Z is the atom number. This atom, the nucleus of this atom, sorry. The nucleus of this atom has Z proton and A minus Z neutrons. So, if M capital N be the mass of nucleus, comma, MP and m small n be the masses of protons, mass of proton and neutron respectively. Then mass defect of nucleus delta m is given by delta m is equal to ZMP, mass of Z protons inside nucleus, plus A minus Z into Mn minus M capital N. M capital N is the mass of nucleus. M into this suffix small n, mass of neutron, mass of proton. Now where does this mass go? This mass is lost. Why the difference is there? This mass delta m, या यूँ कह सकते हैं, चलो ठीक है, is converted into energy according to equation E equal to delta m into c square. C is the speed of light. Now where does this energy go? This energy E, this energy E equal to delta m into c square is released by nucleon to form the nucleus. Greater the value of energy released, higher the stability of nucleus, means more tightly nucleon are more tightly bound. Now this energy to be released. I explained you why the energy has to be released. Actually no one was able to explain me why the energy is to be released. I have explained you why the energy released, because to come closer and closer the energy should be small, and in formation of nucleus, and therefore we can say that when Z protons and A minus Z neutron come in to form nucleus, then they release energy equal to delta m into c square. Conversely, we can say that energy required to break a nucleus and keep the constituent nucleon far apart at rest is equal to binding energy. And therefore binding energy of nucleus is given by V equal to binding energy ZMP plus A minus ZMN minus MN into C square. It is the amount of energy to be released, but practically mass of nucleus is not known. But practically mass of nucleus is not known. What we know atomic masses. We know atomic masses. Atomic mass of element, that is mxza. This is called atomic mass. This atomic mass mzxa consists of mass of nucleus and mass of z electrons and mass equivalent to energy which bind the electron with nucleus. And mzxa is equal to mn plus mass of z electron plus mass equivalent to binding energy of electrons with nucleus. Mass equivalent to binding energy of electron with nucleus. But this last one is negligibly small. But the last term is negligibly small. So you can write here, this is negligibly small. So Mn equal to M bracket Zxa minus Z Me. Putting this value here in equation 1, we get So we get BE equal to ZMP plus A minus ZMN minus MZXA or plus ZME into C square. ZMP plus ME, ZME means mass of Z atoms of ZH atoms equal to Z bracket MP plus ME plus A minus Z MN minus MZXA into C square. Hydrogen atom has one electron, one proton, so it is mass of Z, or BE equal to ZMH, mass of ZH, plus A minus Z, MN minus M bracket XZA into C square. If the atomic mass and mass of nucleon is in atomic mass unit, so we can write BE equal to, you can write as 1U into C square, 931.5. So, if masses are in AMU, then BE equal to ZMH plus A minus ZMN minus MZXA into 931.5 upon C square MEB. So this is the binary expression for binary of a nucleus whose atom number is Z, mass number is A. So I will take further discussion on binary energy in coming videos. The binary or masses have been measured from 1930 to 1950. And many predictions are made based on this. I will come in next video. Thank you.